I welcome you all to Maths Guru channel. Today we are going to treat the topic logarithm. This topic is just an introductory aspect of logarithm and is to aid us in resolving logarithmic equation. Here we have the definition of a logarithm. That is, the logarithm of a number, say n, to a base b is the index x to which b must be raised. That is, to which the base must be raised to be equal to n. So here, if we have, say, log 3, 5, and we have, let's say, 2 here, for instance, the logarithm of 35 in this case is the index which 2 must be raised to be equal to 35. The index to which 2 must be raised to give 35. That is the logarithm of 35. Now, we have examples here. Log 25 base 5. That is, what is the index to which 5 must be raised to give 25? If we raise 5 to the power of 2, we are going to have 25. Therefore, the logarithm of 25 to base 5 will be equal to 2. So, the logarithm of 25 to base 5 equals 2. Now, we have log of 10,000 to base 10. How many times are we going to raise 10 to give 10,000? That is, 10 times 10 times 10, we give 1,000 times 10, we give 10,000. So it means if we raise 10 to the power of 4, we are going to have 10,000. Therefore, the logarithm of 10,000 to base 10 is simply equal to 4. Now, we have a logarithm of 16 to base 2 here. Since the base is 2, we talk of what number do we raise 2 to give 16. That is, how many times are we going to multiply 2 by itself to give 16? 2 by 2 is 4 times 2 is going to give us 8 times 2 is going to give us 16. It means 2 raised to the power of 4 is going to be equal to 16. Therefore, this number, that is the index to which 2 is raised to give 16, is the logarithm of 16 to base 2. Now we have 36 base 6. In other words, how many times are we going to multiply this base by itself to give 36? That is, 6 times 6 is 36. That is, 6 raised to the power of 2, we give 36. And so, the logarithm of 36 to base 6 is equal to 2. Now, the fifth number here, we have logarithm of 81 to base 3. How many times are we going to multiply 3 by itself to give 81? 3 times 3, we give 9 times 3, we give 27 times 3 will give 81. That is, 3 raised to the power of 4 is equal to 81. Therefore, the logarithm of 81 to base 3 is equal to 4. I believe these examples we have resolved are quite clear. If it's not clear, they are not clear to you, kindly revise your video as many times as possible to get used to these examples. Now, how to write index forms in their logarithmic forms? We know that indices and logarithms are quite related. So we can simply write index form in their logarithm form. But recall that we say that the logarithm of a number, say 125, is to the base, that is 5, is the number of times 5 will be raised to give 125. So we can still transform this back to the logarithmic form to give, that is log 125. This becomes the base, that is 5, is equal to what? 3. So this is the logarithmic form of this index form we have here. Again, if we want to write 81 equal to 3 raised to the power of 4 in logarithmic form, we simply have the log of the main number, which is 81, and this, the base we have here, becomes, that is 3, serve as the base of the logarithm, and the power, that is the index, is the answer to this logarithm. The answer to the logarithm, that is equal to 4. So we can simply resolve others like that. Log 8 base 2 equals 3. And this we have log 25 base 5 equals 2. Here we have log 343 base 7 equal to 3. So this is how we transform index forms to their logarithmic form. So we have the main number expressed as a logarithm, then the index part, that we have something like 81 here. We have 3 as the base of the logarithm, and the power, which is the index, also we refer to the result of the logarithm. Remember our definition of logarithm. Let's move on. We have laws of logarithm just like we have laws of indices. Now, this can also be equated to product rule, the product rule. So we have two numbers of the same base multiplied. If we have two numbers of the same base multiplied, their logarithm is just the logarithm of one of this number plus the logarithm of the second number. So we have log of P plus the log of Q to the same base to give the log of P times Q. Now, if we have something like log, let's say 25 times log 100 base, let's say 5, we can simply write our result as log 25 base 5 plus log 100 base 5. And that's, we have the result. The same way we have, the B part now, we have, let's say, a sort of the division law. The division law. So if we have numbers of the same base being divided, like P being divided by Q, and they are of base B, we can simply write their logarithm this way. We have the logarithm of the numerator, that is the dividend, minus the logarithm of the denominator or the divisor. Remember that if we have P over Q, we have this as a numerator. We can also call it the dividend, and we can call this the denominator or the divisor. Take note of this. All these terms may be used as we move on. Now, in the C part, that is the law C part, we have log of p raised to the power of n. That is, the number we're looking for has an index and base b. We can simply bring the index backward and multiply by the logarithm of that number. For example, if we have log 25 raised to the power of 2 base 5, we can simply say it is equal to log, that is 2 log 25 base 5. Other procedures will follow. For the sake of this, we are going to stop here for now, though we can resolve this to give a log 25 raised to the power of 2 base 5, and at the end we're going to have 4 as our answer, but we shall see how we come about this result later on. D part, that is the D law. D law, we have log b base b equal to 1. That is, any logarithm to its base is equal to 1. Examples, log 10 base 10 is equal to 1. This is why when we press log 10 on our calculator, because it is in base 10, we always have 1. So, others include log 5 base 5 equals 1. Log 6 base 6 equals 1. Log 8 base 8 equals 1. Log 16 base 16 equals 1. Any logarithm to its base, we give 1. Take note of that. And the final law we're going to consider here is log 1. Log 1 is always equal to 0. To base b is to any base is equal to 0. So logarithm of 1 is equal to 0. You recall that any number raised to the power of 0, as we have in indices, is equal to 1. So log 1 will be equal to 0. You remember that we have transformed this in logarithm form. This is the same as b raised to the power of 0 equal to 1 in index form. So when we transform it back to the logarithmic form, we are going to have log of 1 to be equal to 0. That is always how it is. Take note of that. Now, let's discuss the change of base. The change of base. If we have log of p to base b, we can rewrite it as log of p over the log of b. We can even write it as log p over log b. You can put any base you want to insert is permitted. So we have log of n, number 2 here now. It's number 1. Number 2, log of n to base m is equal to log of n over the log of m. If we have, let's add other examples. If we have log 100 to base 25, is the same thing as log of 100 over log of 25. We have the change of base. You can change the base to p. That is your own. Anyhow you want to manipulate the base, you can manipulate, but let it be of the same base. So if we have log 36 base 35 base 5, we can have it as what? Log 35 over log 5. So this is how we transform the base, or we change the base of logarithm. Now, we have a question here to resolve using that change of logarithm discourse that we just stated. Here, that is simply what we're going to use. If we have log b base a times log a base b, we are required to show that this is equal to 1. All we need to do is, remember, we're going to change the base here. We are going to change the base here as well. So we simply have what? Log b over log a multiplied by log this part now, log a over log b. Remember, we have log b here, 1, log b in log b, 1. Log a in log a, 1. Log a in log a, 1. So 1 times 1 equals 1. And 1 times 1 over 1. 1 over 1 is equal to 1. By so doing, we have proven that log b base a times log a base b is equal to 1. Alright, so I feel like resolving other questions in logarithm. That is why I quickly added these two questions here. We have log 81 base x equal to 4. We are expected to find the value of x. Remember, this base is to carry this as the index to be equal to 81. That is, 81 is equal to x raised to the power of 4. The index to which x will be raised to give 81 is the logarithm, and that is what we have here. But now, what number represents this x? That is, what number can we raise to the power of 4 to give x? To give 81. And if we look for the multiples of, the factors of 81, we can simply have 9 raised to the power of 2 is 81. But it's not raised to the power of 4. So if you must resolve questions in mathematics, you should be good at manipulations. Have to be able to manipulate numbers. So if 9 raised to the power of 2 will give us 81, it means 3 raised to the power of 4 can give us 81, equal to x raised to the power of 4. Now, the index here is equal to the index here. We can now equate the base. Therefore, we simply say x is equal to 3. For they are at the base form. Now, the second one, the third example here now, we have half log 64 base x equal to 3. There are many ways we can do this, but let's follow this way for the sake of this lesson. I can simply say multiply both sides of this equation by 2. So if I multiply here by 2, definitely half is going to be out of this place. Yes, half is going to be out of this place. And so I multiply here by 2. 2 times half log 64 base x equal to 2 times 3. So 2 can go. We have log 64 base x equal to 6. Remember how we change logarithm to the index form and index form to logarithm form. So we can simply say 64 will be equal to what? X will go and take this as a power. That is x raised to the power of 6. Now, the question is, what number can we raise to the power of 6 to give 64? we know that 8 raised to the power of 2 we give 64. Okay, what if we say 4 times 4 times 4? It will give us 64 as well. 4 times 4 is 16. 16 times 4 will give us 64 here. But it's not up to 6. Okay, let's test 2. 2 times 2 times 2 times 2. 2 times 2, 4 times 2, 8 times 2, 16 times 2, we have 32 times 2, and that will give 64. So 1, 2, 3, 4, 5, 6. So it means 2 raised to the power of 6 is equal to x raised to the power of 6. Since the power are the same, we can now equate the base. That is to say, 2 is equal to x. We have s to be equal to 2. This is how to simply resolve any equations of this form. In our next video, we're going to treat how we can resolve logarithmic equations.